org2b, Unit 7. Today is Tuesday,
the 24th.
January 24. Get ready to write down the standard. Part of what we're going to look at today is going to go with standard 4. We're going out of order, but my plan is, well, I frustrate students at the very beginning by just going order when you can stick around for, okay, I think they'll get that, and then the next part, oh, for sure they'll get that. Then next time, we'll get a little into the heavier stuff. Also today, with the goal of giving half and half so that some people can have 30 to 40 minutes to address some of this old stuff, and for some of you 30 to 40 minutes to be able to slip out a little bit early. So the standard that we're looking at is standard 4, also called the learning target. Some of these I forget to write most of the time, but hey, today I'm on. Let's see. This one, let's see, it's standard 4. I should put an S for standard 4. And this one is I can factor. Factor is a key word. I can factor a polynomial. Polynomial will be the main thing you'll be working with. A good old-fashioned polynomial, x cubed minus 2x squared minus 8x minus 35. That thing is officially called a polynomial. Whenever you have a string of those guys separated by a plus or minus sign.
If it's more than 3, it's polynomial.
Well, you know,
If it's 3, it's trinomial.
Yeah, I mean, they have, the small ones have the individual names, but technically they all can be called polynomials. But yeah, you're right. Generally don't mess around with that. Find zeros. This find zeros thing is technically what we're about to do. Oops, not it is, but it's zeros. Can I put down the whole thing?
Oh, we did the xintercept way.
And sure. Construct a rough graph.
I do that. I don't know. Make it
This.
Keep writing, right. Keep writing. We're getting up. All right, with your highlighter, let's highlight some things. Again, math, language is important. Somebody doesn't know what a function is, or like, what are you even talking about? Polynomial, like, what is that? So all the words matter. Here we go. Here we go. What do I want them to highlight? Start with the divide. Divide. Okay. Highlight divide.
Oh.
Now there is an old school way. There's an old school way of dividing this long polynomial by this x minus 5, which is part of what they have on the assessment. There's one little piece where they have you do that. Turns out that one little piece tends to be so confusing that for now, my plan is to not introduce the long division. Let everyone just miss that little piece, but get this larger portion. I may at some point just show it really fast, that way if someone picks it up, boom, sure, I'll take it, but it's not the piece that you need to be worried about. To do it the long way, they figured out there's a shorter way to do it called synthetic division. And so what happens with that is, first you take this second guy here, and you write him out front, but the opposite of him, called a 0. Now there's a lot of words that are going to mess up a lot of people, but when you hear 0, here's what you should think. Let me draw a small little picture.
Oh, wait, 0 is 5.
Let me draw a little picture so that when you hear the word 0, if I were drawing this picture, it probably looks something like, let's see, it looks something like up and over like that. Me just looking at this, and they want you to know how to be able to do this as well. You see a long polynomial, and they ask you to sketch a picture. You should be able to sketch that red line as the polynomial. You don't know any of the numbers, where they go, but you should know if it's a cube, it's going to be a wiggly S. If it were a 4, it would be a W. All right, so let's get this thing in here. What are zeros? Zeros are the same thing as a x-intercept. So this guy here is going to be called a 0. which is just an xintercept. Even though I need all the space to the right in a moment.
So is that on 5?
Is what on 5?
Is the dot on like 5?
It is not. Oh, even though I guess it could be in this case. I was just doing it randomly, but it might just
Oh,
be.
but you're saying that it's not exclusive to each other. Like it doesn't have to be on 5. That's just a coincidence.
Right. In this case, just coincidence. I was just drawing to say, whenever you hear 0, please find the 0. If it were a picture, all they're saying to you is, hey, please find the x-intercept. Where does the red line hit the x?
But in this case, it isn't.
I think it actually will be.
Right, this 0 is 5.
Right. All right. So here it comes. 0 is 5, so in this case, just like Ron. This is what Ron and Sam were saying. In this case, it happens to be that, but that's not my goal of that. My goal of that was just to say, when you see a picture like this and ask for 0, it's where it hits the x-axis. All right, here we go. Synthetic division, just so you will have heard the steps. With your highlighter, please highlight the coefficients of the polynomial. That's math talk for. Oh, what are the coefficients? Ouch. What are the coefficients? Say it again. Base. I wouldn't think of it that way. Let's find out if it means the same thing. Was someone else going to say something? What the coefficients are in here?
The number before the x.
Yeah, it's the coefficient of the number before the letters. So do me a favor with your highlighter. Highlight, even though do I have highlighters on mine?
You do. Look at all the way right there. There you go. You have to be on the mark. There you
Go ahead and highlight. Uh-oh.
What is it?
X would be 1.
I like how you did that with the light. I don't know why.
I know. Let's see if
So cool.
You got
I know. I'm selecting it. Then we'll
Yay.
All right. Good.
it. But you gotta highlight it like.
Oh.
Highlight the
Wait,
coefficients,
35
please.
is a coefficient.
Technically, yes. The letter that's behind that 35, or any constant, is x to the 0 power. So you got x to the 3, you got x to the 2,
We get
x to the 1.
okay.
Yeah. So the goal is highlight those numbers. Just the number, not the letter.
35.
Oh, you highlight the next.
Coefficient of the base.
I'm not sure what we use for base in this case.
It's
The letter is the base of the coefficient, but the coefficient.
coefficient is the number.
Yeah. All right, here we go. Next step. Once you have those coefficients, you rewrite them. Once you rewrite them, the number that you were going to divide, this is again why there's so many pieces here, which is why I almost want to skip this, but I'm not.
Oh, yeah.
You always write the opposite. So right here, I want you to put opposite. Opposite of x minus 5.
We're doing 5 minus x.
No, opposite in the sense of they want.
Oh.
So this is a positive 5. I'll put a plus sign there instead of the minus. Now imagine you had to try and do this on an assessment already. It's a lot of pieces to the puzzle. But in the end, once you get started, it's nice and easy. Here it goes. The 1 that's in front of the x cubed, brought that down. There's a -2, there's a -8, there's a 35. That's no big deal. How do I divide this with synthetic division? Step 1, bring the 1 down, and the instructions are down here. On the back of the page is going to be a long version, but I want to give you the short version so you've heard it. Here it comes. Drop the 1 and multiply. 5 times the 1. 5 times the 1 gives you a 5. Then you add down. Notice this. Highlight this add.
This is so
Yeah, it will be.
Yeah, you kind of confused me right now.
What are we gonna use it?
Never. All right, so here it goes. -2.
No, unless we go into
No. Yeah. -2 plus the 5 gives you the 3.
Oh, I get it.
Next step, the 5 you multiply times the 3, and then bring it up. So take a look at it. That's where the 15 came from. Then you just add down again.
It's like a me.
Negative 8 plus the 15 gives you a 7.
This is kind of fun.
Same move again. Multiply the 5 times the 7. Always multiply, move up. Multiply, move up. There it is. The 7 times the 5 is a 35. You're hoping, yeah, to get a 0 at the end. So after you do these numbers, that last column, you want the numbers to be the same numbers, but the opposite sign, so that you'll get this 0 here.
Oh.
And this 0 here at the end is what says to you, is 5 a 0 of this problem? The answer is, if you get a 0 at the end, yes, it is a 0. But like, what did I get? Like, what do you mean a 0? That is, if I drew the picture, would this actually be a 5? And in this case, we found out that it actually is 5. Well, maybe not write it there. Someone who had to do the long version of it, and this is the easier version
I
of
have a
this.
question.
All right, what you got?
So once we get to the end,
That's another step, but go ahead and say it.
oh, okay. So are you removing an x from each one? So it used to be x cubed, now it's x squared, and like the same for the other ones.
Right. So essentially, the question Simon asked, back row, once you do this division, kind of what has happened? In the end, when it's time to rewrite this row as the answer to the division problem, which is why these are crazy, you start with if this is a 0, he is out of it. He is the remainder. We don't need him anymore. 7 is just written as a 7. The next guy in line gets an x. The next guy in line gets an x squared. And if there was another guy in line, you would get x cubed and so on. What is it that I want them to have so far? Here are the pieces I want you to have so far. 1, if you were given a division problem, which I'm about to give you, I'm also going to make yours x minus something. I should make it x plus something so that you know that out front you would do a negative sign, but I'll still make it look exactly the same. What do I want them to know? If they're given a division problem like this, step 1, the factor is rewritten with the opposite. They pluck off the exponents, or rather the coefficients. They drop the first one and multiply. Once you drop it and multiply, you go through that motion of bring it up, add. Multiply, bring it up, add. Multiply, bring it up, add. Alright, let's have you go through the motion. It may be meaningless to you.
Wait. Okay, so I think I get it.
Alright.
But the problem will look like that on top.
The problem that you're going to try. This time we divide it by x minus 5. The second time I want you to try it with x minus 7. Uh-huh. I hate to write the whole thing. I know that two people have a question. It's the same one. What's that word? I'm just writing out the whole thing. Oops. That's not right. Okay, so it's right. The clock. Oh, why is there a high? Oh, it's folding. Try this problem on the board. Try this problem on the board. Synthetic defects. Here we go. Step one. It was a 1, a 2, an 8, a 35. They put a 7 in the house. They drew a line below. They dropped the 1. Then they multiplied to get a 7. What is this? A -2 and a 7? 5.
I added these.
7 and a 5 gives you a 35.
You get 27 from that.
I thought you get 35.
You multiply these two.
7 times 5.
8 and a 35?
47. I think.
Yeah. Oh, then it gets really big.
Yeah, it gets 945.
What?
Dude, that was
What's the 7 in the 27?
189.
Now here's the good news for those who get a big number.
It's you're gonna end up with 1.
You know it's not going to be a 0 here.
So do we just not?
So let's just say even if you weren't that good with messing around with big positive negative numbers, you can stop there. Even if you want to just kind of put a no, you could. But what did it actually come out to?
154.
154.
Honestly, don't know.
What's the no?
That is for a student.
It should be up.
Yeah. For students who couldn't mess around with the big numbers, all right, don't stress yourself. Just know if it's not a 0 there, then this 7 is not a 0.
No, if I can say I'm gonna keep
No,
it.
all right. One other thing I need you to write. This guy here, write the word factor.
Wait, no. I have a question.
Answer.
Okay, once we put down all of the things,
Mm-hmm.
and I set it up, it ended up being plus 27 plus 154. Do I add those together?
No, these two. This guy would be considered a remainder.
So I just stop without writing down what the function.
Right. You don't have to break this up. But if you did,
A reindeer?
Reindeer? It's a friend of mine. All right. All right.
Chop, chop.
Alright. Now, if you are like me, let's see, I'll put this 27, 5x,
What is that?
there's a 27, there's a 5, the second guy in line gets a letter, third guy in line gets a square. But here's what's important, let me, and then I'll take your hand. So you don't think you have to know it all, the part that I want you to be able to know is, take the coefficients, do the opposite of the one that you're trying to find out if it's a factor, whether if it's a 0. Pull down, multiply, pull down, multiply, pull down, multiply. There are a couple of questions out there. We'll flip to the back of this thing, then I'm going to get you to another topic that is easier, but super important. I thought there was a question here. Technically the remainder is written this way. This is going to be ugly.
I feel like the farther we get into it, the more confused I get.
Oh, it's supposed to be confused.
But then I realized.
So if you feel confused,
7. You put a 7 in it.
I think it's the
I
X.
get it, and I'll help you. Not right now.
You don't need to know all the stuff, but I just want you to take, so if someone says, hey, can you do synthetic division? You're like, oh yeah, I've done that once. It's where you put the pieces down.
That's in my part.
Any other question on this?
Yeah, can you
Alright.
put the parentheses around the x minus 7?
You can, yes. Do me a favor, flip your page over, please. Flip your page over.
Just get five. I have all my pictures out for graduating, but I need it because
All right.
I didn't do math.
Mine is fuzzy.
Yeah, I didn't.
All right. Oh, I'm going to get the other thing in. I think I can do it. The back version is just an extended version of synthetic division. So do me a favor at the top, please highlight the x minus 2. Please highlight the x minus 2.
It's plus.
Is it plus 2? Sorry, x plus 2, thank you. Highlight the x plus 2. Next, please highlight the minus 2.
Every problem?
No, just on this first one. The reason you're highlighting that is just to remind you again, when they ask you to do a division problem, in the end, when it's time to put in synthetic form, you use the opposite. The next thing that's important here on this one, even though it's fuzzy, notice if we wrote, we'll try this so that you can mess up and then I can fix it. Please write down the coefficients right below here. Don't do it in pen because it's going to be broken. Write the coefficients directly below the polynomial.
Does it work?
Please write those down. If you know what you're looking for, you're probably done already because there seems to be 3 of them. Write those down right below the problem. I'm watching, I'm looking, some of you are writing, some of you are writing.
Is there something I'm missing?
Let's see if we can fix it. There are supposed to be 4 coefficients.
I would have been.
Which one is missing? There's supposed to be 4.
0.
2, 4, 6.
0 is going to be the correct answer. The question is, where is that 0? The answer is this. Notice here you have an x to the third power right here.
Oh, the x
You're
squared.
supposed to have an x squared somewhere. Well, we skip that to just to the x, and then we have our 8. Well, if one is missing, technically, if you have to write out properly, it would look something like this. I'm going to rewrite the whole thing with that piece that's missing, 5x cubed. He's good. In red, the guy who's missing. If a guy's missing, you put x squared, or you put a 0 in front of it, and then the other guys go there. Take a look at it, take a look at it, see if you're confused. Oh shoot, I'm using up the time on the other part now.
What happened to Jacob?
Yeah.
I don't know,
And then the last part, last part. Here we go, 5, 0,
No. People are like,
6, 8.
yeah.
Good 8.
So right now, take a look at that. You may want to write it down just in case it gives you one of those. Now put that away, Jose, please. What? You may want to put that away for
Wait, so do we turn it into negative too?
yes. Yeah, we highlighted those. So while you were out, we highlighted those.
Oh,
All right, last part on this before we have to switch to the other handout.
Last part.
The next handout. Too loud. The last the other handout though will be one of your 6 pages. All right. So here it comes. If something is missing, you have to fill it in. There's no x squared. There's only an x cubed and an x. So x squared, you have to add it.
Wow. Anywhere in the problem, we got it anywhere.
Put it where it should go.
How do you know it's supposed to go there?
They go down in descending order. 3, 2, 1, 0.
Okay.
Good question. All right, here we go. You're not about to go through all of this. I just want to highlight, once it's set up, they're just going to give you all of the steps. So this is the same thing as on the front, except they stretch it all out to tell you every single step. For example, bring down the 5. Oh, it says bring down the 5. Do me a favor, highlight just the bring. Highlight just the bring. Highlight the bring. Step 2, after you bring down the 5, you multiply it with the 2. Highlight the multiply. Step 3, after multiply the 5 and the 2 to get the 10. Hit the add. Highlight the add.
I knew it.
So again, all they're doing here, instead of on the front where they put it all boom, all together, boom, this one's like separate it, tell them, separate it, tell them, separate it, tell them. So then, so highlight all the keywords, please. Oh man, more time than I planned on, but I'm moving. Alright, let's see if this second part, give me that, just introduce a piece of it, and revisit it next time. Got it.
oh my god.
Did you see the
Oh,
I missed so many moments.
Oh, well, they weren't gonna do this anyway.
how come he says he doesn't like it?
Standard 3, I can. You get there, says
You did put 15. Are you kidding me? I think it's because I was bragging about it earlier. Yeah. I got jinxed.
I mean, I would get it.
I did not know.
I can solve quadratic equations. Write that down, write that down.
X equals.
Alright, thanks so much.
You know, I want to get it.
That has,
We have to write this.
yeah, please write it down. So that when I collect it,
My baby was born.
complex roots.
You got it? My baby. So, me.
Alright, write that down, write that down, write that down.
I can solve.
I can solve
How do you?
a quadratic equation that has underlying complex roots. This is the part that puts you in Algebra 2 second semester.
Kind of twirling on the keys here. I was not.
So you can do this in 25 minutes or less.
Complex roots.
Uh-huh.
No.
Can you pick up? So, a little bit of water. Please write this down. A plus BI. Write that down, write that down. A plus BI.
It goes down
Well,
as
they said for it to be there.
Uh-huh. Write that down. A plus bi.
Oh, no.
Is I the imaginary number?
Uh-huh.
On the stand for TI.
Below roots, please write down 0. Don't write too big. Is it too late?
Never ages.
Write those down, write that down. Here we go. Follow me, follow me. Those are talking, for those who are talking, please stop. Stop. Front row, back row. All right, take a look over here. Please highlight that the radical of a -1, we don't know the answer to it. What's the square root of -1 is asking the question, what number times itself will give me a -1? Anybody know? 1 times 1 is a +1, so that's close. -1 times -1 equals a +1, so close again. 0. 0 times 0 is 0, so close. 1 times 1 is 1, so
There
close.
is nothing.
Right. And because there is nothing, we have to imagine an answer that I represents.
Isn't it
Imagine.
what times
No, next time.
So, whenever you see I, that means there was a -1 under the radical sign somewhere. That -1, they'll never write as a 1. They'll just put a negative sign. So if I want to get the answer to square root of -9, can anyone suggest an answer?
I times the square root of 9.
I'm going to write the answer. 3, come on. 3 to 9 is a 3. But because that negative sign in there, there must be an I
Wait,
with it.
would it be 3 times
It would not be 3 times -I because the negative
Oh, the
one in
imaginary
there
number can be anything.
just represents I. So let me rewrite this problem like this.
I don't get it. I swear you guys like.
-1 times 9 is -9. When you have a negative number, automatically you have the positive version. Multiply times the -1. This represents 2 separate pieces. The square root of 9, which is 3, no big deal. Because 3 times 3 gives you 9. And then that -1, that has to be represented by I. Do me a favor, please, write down the answer number 2. I'm going to come around and check mark that one. Anybody know what the square root without a calculator? What the square root of 15 is?
3.8.
Without a calculator.
We just did it without a
Yeah.
calculator.
Yeah. There is no square root of 15 that's a whole number. And so, the rule will be this. If you get a square root where the number inside isn't one of your perfect squares, 25, 36, 49, what you will do is leave that number inside the radical,
That's right.
and then that -1 still always comes out as the letter I. So in this case, please write down -1, and this is the type that will more likely be on the test. These regular guys, kind of easy, straightforward. This is the one that, again, puts you in second semester of algebra 2 rather. The -1 automatically comes out as I. The 15 stays trapped. And so you're left with radical 15, if I can make it right. Radical 15I. Because because by putting it behind, sometimes it appears the I is under the house or under the radical sign. Usually you will put it in front like this.
Oh,
And this way, you know for sure the I is not inside. It is not. This is -1 times 15. I'm going to make one up for this because this is the only one they made and it's the most important one. Do me a favor, do radical, I don't know, radical 21. Please write down the answer to radical 21. This one will come in check mark.
-21.
We're trying to get to the back of the page. Please highlight. Please highlight that x squared equals -1. What that kind of means is this. Up here, if you were to square this I, you do not have to do this, you just watch this part. If I were to square this I, dang it. what you do to one side, you must do to the other. You don't have to write this. You can just watch this part.
Cancel out
Wait, why do we call it
The
intercept?
square, just follow. The square on this side leaves us just, of course, with I squared. But the square and the radical, they cancel each other, leaving you just that negative 1. You don't have to write that. I just want you to hear that so that when you start seeing it down here, it'll be easy to fill in some of the pieces. So let's start filling in some of the pieces together. Uh-huh.
That's the same problem for
Oh, that's bad news. Okay, here it comes. Number 7. Let me do number 7 for you. 5 times that is the same thing as 5. Write that down, write that down. Write that down, write that down. Back row, side, side, side. Take a look at the answer, see if you're confused.
And clearly.
I squared, or I times I, will always equal a negative 1. So this is really just 5 times negative 1. Again. This guy right here, I squared, just means negative 1. So I squared just means negative 1.
I'm sorry.
You say you took like.
So you're kind of just plugging in negative 1 to I squared and then solving.
Alright, here we go. Let's do 2 more of this type, and then I'm going to turn it to the back, where we're trying to get some of those on the back. Let's see, will this thing come down? Please do number 9. Write down number 9. Let me see what you get for number 9. Done already. Alright, come around for number 9. Raise your hand once you have it. Let me borrow this guy. Number 9. I remember when the best day ever came out. Here. Hands for number 9. And I watched 9. How about them Packers?
You know what? Shut up.
Alright, let's see it. Number 9. Any other number 9?
What?
I know.
Yeah.
Any other number 9? Any other number 9? Hands up. If you're working on it, that's fine. While we go around to the others, you'll be able to. Any other number 9?
Next time I get my answer.
No, the idea I can't do it just at a time. Alright, so these. Alright, so to get on that, 11 is going to be a little bit tricky. And I'll mess around with 15 on this side, and then I will go from there. Alright. Oh no, I was recording while I was walking around.
At least they know the actual setting now.
Alright, negative 6, I saw it in your papers, times a negative 1. Oh. Alright, do me a favor.
Why did you just throw water at me?
We're going to try 11 and 15, then flip to the back. Go to 11, please. Let's see what happens on 11.
Because you said math.
Take a look. The 3 and the 7, I saw some people do this. They got a negative 21.
Yes, I did.
That's how you do it.
The I and the I.
I squared.
I'll put in the I squared first. Take a look at that. See if you're confused. And then the last part, I squared is the negative 21 times a negative 1. And so in the end, I saw that 21 floating around. A lot of people's to become a positive, not 25. That'd be crazy. Pause, take a look at it, see if you want to ask them about any of the pieces. 21, the square, or the pause 21.
It doesn't.
I mean, unless you like it. Even then, it's on me. like, is there anything after?
Yeah,
That's a base.
Please write down the following.
Yeah.
Is that an 8? Or is that a 9?
They're all like one friend.
It's an 8?
There's an apple.
What incarnation?
But they're like dead.
Oh, they should have you.
Let's find out. Raise your hand if you work with the quadratic formula.
Didn't we just do this?
I said that yesterday.
We just did this.
Wait, you speak it different than I do.
I don't understand. There's different.
I speak it like tacos.
This formula right here. Please put a box around this and write down quadratic formula.
Negative b plus or minus b minus 4a.
Over to a. Dude, that was my jam.
Get out.
X equals negative b plus minus b. B squared minus 4 is the alpha 2. Right? So it's
How did I never learn that?
Ryan didn't teach us songs. It was very late. That was 3 years ago.
Is it my English?
That was the only one who had this for Ryan.
I love that. I'm really proud. I have 7 N's.
For those who know the formula, it's all the same to you. The only difference will be under the radical, once you do the work, you're going to wind up with a negative 49 or a negative 7.
Oh, and then we just write as I.
That's a big deal. All right, get ready for it. Let's do one together, one on your own, and then that'll be the thing. We'll do the 19 together. You'll do 20 on your own. Here we go. Do me a favor. Write down A. Ooh, I do different colors. All right, this is the only time we do the different colors. Here we go. A. Oh, it's all going to be in red. Come on, you can do this. You can do this.
Seriously, we have orange presents.
Red, 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 red. Let's go. A. When your B is going to be in green. That'll take time. B. And C is going to be in red. Someone tell me what A is going to be. Oops. The key word is going to be coefficient. Only numbers in front of letters. All right, 1. If you answer a question, don't answer the next one. B. Someone tell me what B is going to be. 10?
I feel like I can't hear anything you're saying.
And 34, right?
For those who are talking, hold on so the others can hear around you, please. So A is going to be 1 as in 1.
1, 10, and then 34, and then can you please not do that?
Next person, what is the B again?
10.
Okay. Not only is it a 10, but it needs to be a negative 10. And then someone different, what is the C?
34.
This is like 5 times.
Alright. So here's the deal. I don't know how much space I'm going to have. Write small because we have to plug it in. Let's see if any negatives.
Know your name, but
So here goes. Negative B.
It makes it into a positive.
Yeah, I'm just going to write the whole thing in black. Sorry.
No, it comes in 6 Michael.
What's up? Say my name. Do me a favor. Put in parentheses.
Yes, Michael. No.
I'm Steven. Please put down parentheses.
My name is Sebastian. What you talking about? Sebastian always something.
Why do I feel like I got something?
That's Marco.
That's Marco.
On the board. Right.
Let's work with
Back row. Right. Put it on the board. When I put mine. Right. Okay. Put in the numbers where they go, please. All right, we got a negative 10. Yes, please.
Yes, please.
What you got? Okay. The reason we put parentheses is because somebody's going to mess up with this red minus sign out front. It wants the opposite. That's what the red sign says, opposite of what B is. So the opposite of a negative 10, of course, is going to be a positive 10. A, what did we say A was? And C?
There you go. I'm sorry, 34.
34, thank you. And then, of course, the bottom.
No anti-Semitism, please.
Right. The bad news is there's not much space, and we're going to need a bunch of space. So for mine, I'm going to write through the next problem.
Wow, savage.
For you, write small. Here we go. This negative 10 is going to become a positive 10.
It's scary.
Anybody know what negative 10 squared is?
Negative 100.
Or a positive 100.
Positive 100.
Positive 100. Calculators, I'm going to need your help. A negative 4 times a positive 34.
A negative 4 times a positive
Negative 236.
Wait,
what? Negative 30.
are we supposed to write in the space of the other problem?
I am because I don't have any space. They may put it too close together.
Negative 130.
Oh, yeah, negative 136.
136?
Yes.
Can I just write it like the side of it?
Yeah, you can put it wherever you can fit it. I'm just doing mine here.
But it's negative 136.
Negative 136.
That's because markers are.
No, when you're multiplying, you take this guy times all the, whatever the sign is on that answer.
I know, but it's 100 minus negative.
Oh, I thought you were saying,
Yeah.
is this a negative? Yeah, in the end, it's in 1. That's negative 36. Which is the point. That is a negative.
I know, but shouldn't it be 100 minus negative 136?
No. When it's time to do the work here,
36.
you take the 4 as if it's a negative, which means you're taking that minus sign that you're talking about already and you're using it. So when you finish, you have this. Write down, take a look, see if you have any questions.
Oh, okay, I understand.
Next step. The 10 stays out front, no big deal. Somebody say out loud, 100 minus 136.
Negative 36. Plus or minus 1.
It's just the formula?
Printing.
Question.
Yes, please. I'm not sure. Double check with your teacher. Some say different things, so double check with your teacher. Final answer.
10 plus or minus 6 pi over 2.
Oh, that does come out, doesn't it?
I mean, I don't do it.
6i, right?
Yeah.
Asian people.
Did you say Asian?
Yeah, she don't like me.
Can you just do 5? 5 and then have that be 3?
No. For now, I say keep it as this. The most important part is that I part.
Wait, is it still correct if I put 5 plus or minus 3?
Yeah. As long as you have this before that, then yeah, you're good.
Honestly, what should I
That makes me laugh a lot.
Write it down. Take a look.
That's the answer.
That is the answer.
Oh, nice, wonderful.
Okay, I understand.
Notice how you have those 2 x's? Technically what you found out right here are 2 zeros. In other words, x equals the positive version, 10 plus the 6i over 2. And then x equals the negative version, 10 minus 6i over 2. What is your job? Your job is to do number 20. What's the most important part to me? If you get right here, where you have that negative 36 under there, then I know you know what you're doing. If you don't get there, once you get there, raise your hand so I can see what you have.
I'm already there.
Are you having tutoring day?
Which one are you on?
I've only seen up to
Oh, the 10 plus or minus 36? No, because
I should have done this first.
6 to 6i. So it comes down to 5 plus or minus 3i.
Should have did that.
That's what I got.
That's the definition.
It's basically this. The quadratic formula is literally almost or not this, like this is
Yeah, I got that.
And when you put in, did you put a 5 here? Of course.
Yeah.
and
And then you did 4 times 5. Uh-huh. See how we did here?
So wait, sorry, so would it be 4
well, you can see how it's got a
negative
blue
4 times a negative times a negative is positive?
Yeah.
Actually, it'll be a negative 4 times a positive 5.
Yeah.
Wait,
But since okay, since A times B, so it would be negative 4
Yes, I got me confused.
negative 4 to 16.
No, the negative 4. Write this part down. Let's see what you have. Once I see that one, that 1, 5, and I'm about to write down the setup number.
Actually, I just touched for it.
Come around and check mark your setup.
But how do you work? Are you trying to get this? What's the same reason?
Some of you have finished, and you got it right.
Wait,
Uh,
The funny thing, I watched the stuff to stick with
have you got your license?
the watch goes, why are you following me?
Oh,
I
got it.
I
got it.
Why are you
I got
following me? What do you mean? Why are you following me?
You're like her mailman.
So why are you following me? I'm recording you. And he was there like,
Alright, let me have your attention. Let's get this part in here. And now I used up your brain power on the synthetic division, which if I had to do over again, I would do this part first and save the synthetic for later. Just hold. So for what I want to do here is at least put the pieces where they go. And what I want you to do, let's say if it's on a test, which they'll have some of these, this first step will allow me, if you mess up later on, to consider, okay, can I give them the points because they have it in the right place? So what goes in here for the B?
negative 4. C.
The negative 4 goes there twice.
1,
Mm-hmm.
5, and 1.
Yes. I want to come around and check mark this part on you. If this part is good, then I know it's coming. The rest of it should work out, and then I'll put in the rest. So quick, come around, check mark, then I'll finish on the board. Positive 4. Plus or minus. All right, positive 4. Plus, minus. That's 16. Minus of 20.
Over 2.
All over 2. 4. Sure, I'll do it again. Plus or minus a negative 4. Okay, let's come down. Wait, give me space. No, thank you. All right, over 2.
Yes.
Final answer. Yeah, don't do it. Take a look. I checked it off.